Yes. Hello students, welcome to Gradeup, India's largest online platform for GATE, ESE and PSUs for other competitive exams. Students, all of you good afternoon, welcome to the session. Yes. Ashok, good afternoon. Kanchuma, good afternoon. All of you good afternoon students, welcome to the session. Continuation of Synchronous Mission series. Today I am going to solving the important models of questions based on EMF Equation of Alternator. Who are preparing for GATE, ESE and PSUs, these models of questions are important students. Students, all of you, good afternoon, welcome to the session. Yes students, before starting the today topic questions, first let me introduce myself. Students, my name is Surendra. For 10 years, I am educating the students for GATE, ESE and PSUs in electrical and electronics engineering. So these are the subjects I am teaching for various competitive point of view: network theory, power electronics, electrical machines, power systems, electrical and electronic measurements, control systems, transducers and mechanical instruments. Yes students, this is our Gradeup Super. Who are the aspirants for GATE, ESE and PSUs for structured course, subscribe to Gradeup Super. This is our mega mock challenge schedule for September for electrical engineering. Please go through this schedule students. This is my Telegram channel. Who are the aspirants for GATE, ESE and PSUs. For more updates about my lectures and if you have any doubts clarification, you please join this channel using this link students. Yes students, all of you, good afternoon, welcome to the session students. Yes, Mani, good afternoon. Welcome to the session students. All of you, welcome to the session. Yes. Good afternoon. Yeah. The first question is displaying on the screen. Students, come on. This is the questions based on EMF equation of alternator that I am going to solving. Please concentrate students. Yes. An alternator open circuit generates 360 volts at 60 Hz when the field current is 3.6 amperes. Neglecting saturation, determine the open circuit EMF when the frequency is 50 Hz, when the frequency is 40 Hz and the field current is 2.4 amperes. Yes, come on students. Check your knowledge on solving of the questions based on the synchronous missions EMF equation. That is EMF equation of alternator students. Here first I am writing what the EMF equation of alternator. This is E equal to 4.44. Yes students, F pi Kp Kd turns per phase. Yeah, this is the EMF equation of alternator. This is per phase students. This is per phase induced EMF. E per phase. This equation directly indicates use the per phase induced EMF. Yes, all of you, good afternoon students. Welcome to the session. This is the per phase induced EMF. Yes, come on students. What is the observation here? This E is proportional to pi into F into pi. F into pi. Where F is the frequency, pi is the flux, Kp is the pitch factor, Kd is the distribution factor, T per phase, that is the turns per phase students. But you know that flux is proportional to the field current. Flux is proportional to the field current. Excitation. That is E is proportional to pi into IF. How to write students? This E2 by E1 equal to E2 by E1 equal to yes, F2 by F1 into IF2 by IF1. Then what is E2 by E1 students? This E2 by E1 equal to how much frequency? For 40 Hz frequency you want to find the induced EMF. What is F1 students? 60 Hz. What is IF2? Field current is 2.4 amperes. What is IF1 students? Field current is 3.6 amperes. Can anybody answer what is the E2 you can get? That is 40 by 60 students into 2.4 by 3.6 into what is E1 students? 360 volts. Can anybody answer how much you got students? What is the E2? Come on students, come on. Yes. All of you, good afternoon students. Welcome to the session. Please like the session and share the session students. Who are the aspirants for GATE, ESE and PSUs? It is more important models of questions. Mainly you are preparing for GATE point of view also, it is very important students. Yes. Can anybody answer how much you can get this one? This induced EMF you can get 160 volts. Very good money. Very good. Option A is correct. 160 volts students. Very good. Very good. Next. One more question is displaying on the screen. Come on students. Come on. A star connected 3-phase 6-pole alternator. Important model for 2 marks question in GATE exam. A star connected 3-phase 6-pole alternator which runs at 1200 rpm, having flux per pole of 0.1 Weber, sinusoidally distributed. Its stator has 54 slots, having double layer winding. Each coil has 4 turns and the coil is corded by 1 slot. Find the no load line to line induced EMF. You want to find the line to line voltage. First I am writing the EMF equation, then you get idea which parameters you want to calculate. 4.44 F pi Kp Kd tons per phase. Yeah, this is the yes friends. Already flux is given. Flux is how much it is given? 0.1 Weber. Yes, no need to find the flux. Yes friends, but frequency is not given. Instead of frequency, number of poles is given and speed is given. You know that Ns equal to 120 F by P students. Then I want to find frequency Ns into P by 120. Ns into P by 120. How much speed? 1200. How many number of poles? 6 poles. This is how much you can get students? 60 Hz you can get. A frequency we can get the 60 Hz. Yes. Devendra, good afternoon. Kanchi Maithili, good afternoon. All of you, very good afternoon students. Welcome to the session. We are getting frequency equal to 60 Hz. Okay. I calculated F. I know the pi. Then I want to calculate Kp, Kd and tons per phase. First I am calculating the tons per phase students. How to calculate the tons per phase? Come on students. If stator has 54 slots having double layer winding. Yes. We know that in double layer winding means in double layer winding. What are the conditions students? In double layer winding, number of slots directly indicate the number of coils. Number of slots equal to number of coils in a double layer winding. Come on students. Number of coils. Here each coil has 4 turns. Means each slot is having 4 turns. Then total number of turns. The total number of turns is 54 into 4. Yes. 54 slots. Each coil has 4 turns students. Then how many number of total turns students? Can anybody? How many you can get? Yes students. Come on. How many number of turns we can get students? 216 we can get. Is it correct? 216. But I want tons per phase. I want tons per phase. It is a which alternator? 3-phase alternator. Yes, Shubhadeep. Good afternoon. Welcome to the session. Thank you. Thank you. Yes. Amit, good afternoon. Mani, very good. It is a 216. What are the tons per phase students? Tons per phase is 216 by 3. Then how much you can get students? Can anybody? 72. The tons per phase we are getting 72. Very good money. Yes. Amit, good afternoon. Yes. Shubhadeep, good afternoon. All of you welcome to the session students. Devendra, good afternoon. Yes, you have the synchronous mission in diploma. Then this model is also there. Yeah, it is useful. Devendra. But concept you concentrate. Not only the what is the model of the problem. What is the length of the problem that you don't concentrate here? You are particularly you studying diploma. Concept you concentrate. Which formulas we are using? Totally it is a English session, Devendra. Sorry for that. Yes. Yes, friends. The tons per phase equal to 72. Yeah, you can easily understand. You please not the language here. You concentrate the formulas, concept I am explain. Tons per phase equals 1. Then I want to calculate the pitch factor. How to calculate the pitch factor, students? How to calculate Kp? I already given in the previous session Kp and Kd calculations. How to calculate Kd? Yeah. To calculate Kp, here data is given, students. The coil is carded by one slot. Short pitched by one slot. Carded means short pitch. Carded means short pitch, students. Yes, sir. Carded by one slot. Alpha equal to one slot, students. The coil is carded by one slot. One slot. That means I want to find the slot angle. First I want to find the slot angle. To find the short pitch angle, first I want to find the slot angle. What is the formula for slot angle, students? Each slot angle gamma equal to 180 into P by S. This is 180 into how many number of poles, students? Come on. How many number of poles it is given? Yes, 6 poles. How many number of slots? 54 slots. 54 slots. It is a 6 poles, 54 slots, students. How many degrees we can get? 20 degrees. Now you substitute here alpha equal to 1 slot means 1 into each slot angle is 20 degrees, students. Then alpha we can get 20 degrees. Then first I am finding the Kp. What is the Kp, student? Cos alpha by 2. Cos alpha by 2. This equal to cos 10. This approximately equal to how much, students? Can anybody answer? What is the cos 10 you can get? This approximately equal to 0.98. Is it correct, students? This approximately equal to 0.98. Come on, students. What is the Kp you can get? 0.98. Okay, I got the Kp also. Frequency I know. Flux I know. Tons per phase I know. Then Kp also I know. To find the induced EMF, the next one is Kd. Kd. Manikandan, sir, please give some important notes about the topic before questions like reading. Okay, Manikandan. The next class onwards that I will. Next class onwards. Actually, in this total only one formula only, maximum EMF equation and harmonic EMF equation. That's why I'm not given that one. This is important formulas for next coming questions. Okay, I will give. Very good, Mani. Very good. Yes, friends. 0.98. How to calculate the Kd? In the yesterday session, in the previous session, I given this formula. Sin m gamma by 2 by m sin gamma by 2. M sin gamma by 2. Okay, this is Kd, students. What is M? M equal to slots per pole per phase. Slots per pole. How many number of slots, students? 54 slots. How many number of poles? 6 poles. 3 phase. Then how much you can get, students? 3. Then how much Kd you calculate? Come on, students. Come on. 3 into gamma is 20. 20 by 2 by this is 3 into sin 10 by 2. Gamma is sin 20 by 2. Can anybody answer how much you can get this one? Kd. How much Kd you got, students? Okay, thank you, Manikandan. Yeah. Okay, Manikandan, you can ask. Yes, friends. This is how much Kd you got, students? Can anybody? You simplify this one, you can get 0.96. Then what is the induced EMF per phase? Please concentrate how to calculating the EMF. Fundamental question, students. 4.44 F pi Kp Kd tons per phase. Tons per phase. Yes, students. Come on, come on. How much induced EMF per phase we can get? The induced EMF per phase, how much we can get, students? 4.44. Frequency 60 Hz that I calculated. Flux is how much it is given, students? 0.1. Kp is how much you got, students? 0.98. Kd is how much, students? 0.6. 0.96. This is 0.98. 0.96. 0.98. 0.96. How many number of tons per phase, students? How many number of tons per phase you calculated? Come on, students. 72. This is 72. I'm writing clearly. Sorry for this. I'm writing clearly. It's not visible. Yes, students. This is equal to 4.44. F is 60 Hz. This is 0.1. This is 0.98. This is 0.96. This is 72. Can anybody answer how much induced EMF surface you got? How much induced EMF surface we got, students? Very good, very good. 1805 volts we can get. Very good, sir. Then, but the question is asked line voltage. It is a star connected. Line voltage equal to root 3 times of phase voltage. Root 3 times of phase voltage. Root 3 into 1805. Root 3 into 1805. Can anybody answer? How much you can get, students? It is nearly equal to 3125 volts. It is nearly equal to, very good man, 3124 volts, 3125 volts. Is it correct, students? Then which option is correct? Which option is correct? This model we can expect for 2 marks question. This model we can expect for 2 marks question. 3125 volts we can get. 3125 volts we can get. Come on, students. All of you, good afternoon. Welcome to the session. You please like the session and share the session, students who are the aspirants for GATE, ESE and PSUs. It is more useful. Yeah, the previous question answer is 3125 volts. Very good, man. Yes, come on, students. One more question is displaying on the screen. Come on, can anybody answer this question? Yes. A 3-phase 50 head 10 pole alternator with 90 slots has a star connected winding to give a generated EMF of 22 kilovolts at no load. The coils are corded by one slot. If flux per pole is 0.11 Weber, then number of turns required per phase is. You want to find the number of turns required per phase, students. Here, unless otherwise specified, it is a phase EMF or line EMF, it is not mentioned, students. But in 3-phase, whatever the 3-phase voltage it is given, you take the line voltage. How much line voltage, line to line voltage is it is given, students? 22 kV. 22 kV. That is 22,000 volts. Unless otherwise specified, in 3-phase, whatever the voltage is given, that is the line to line voltage, students. But I want phase voltage. What the per phase voltage? It is a star connected. 22,000 by root 3. Okay. It is okay. But here we want to find which one? Number of turns per phase. Number of turns per phase we want to find. You know this equation, students. E per phase equal to, first write down the formula, then you can get idea which parameters you want to calculate. Which parameters we want to calculate. Come on, students. Come on. Yeah. Frequency it is given. Frequency 50 Hz is given. No need to calculate. A flux is given 0.11 Weber. No need to calculate. Then EMF is also given. You want to find the Kp and Kd. The coils are corded by one slot, students. To calculate the Kp, you want to find Kp and Kd first. To calculate the Kp, alpha is how much it is given? One slot. First find the slot angle. The slot angle gamma equal to 180 into P by S, students. Come on. This is 180 into how many number of poles, students? 10 pole. How many number of slots, students? 90 slots. How many degrees we can get? 20 degrees we can get. Then what is alpha? Alpha is 1 into 20. That is 20 degrees we can get, students. Then we can calculate first Kp. Yes. Yeah, previous one 3125 volts approximately. Surendra Kumar, very good. Yes. Per phase. You given money, you given for this per phase. Okay, no problem. Later on that you will simplify. First you do the Kp. First calculate this. I have already done this one. Cos 20 by 2. Cos 20 by 2 approximately equal to this 0.98. Is it correct, friends? Kp equal to 0. Approximately. Then what is the Kd? I want to calculate Kd. You know this formula. Based on this Kp, Kd, detailed different models of problems how to calculate I already done, students, in the previous session. Please go through that session also. Sin m gamma by 2 by m sin gamma by 2. M sin gamma by 2. Come on, students. Come on. What the m equal to? Slots per pole per phase. Slots per pole per phase. How many number of slots it is given, students? How many number of slots it is given? It's a 90 slots, 10 poles. 90 slots, 10 poles, 3 phase. This is we can get 3. Then you substitute here KD also you can get same value as per previous problem. 3 into 20 by 2. Yes students. 3 into sine 20 by 2. How much you can get students? This we can get a 0.96. I think you got 0.96. Then remaining you substitute all these. Remaining you substitute students. 22,000 by root 3. 22,000 by root 3. 4.44. 4.44. F is 50 Hz. Flux is 0.11. This is 0.98. This is 0.96. You want to find the tons per phase. Can anybody? How many number of tons per phase we can get? Come on students. How many number of tons per phase you got? Come on, come on. Yes students. Using same formula you are calculating number of tons per phase. Come on. How many number of tons you got? Very good, very good, very good Amit. This we are getting 550 tons, nearly equal to 550 tons per phase. It's a nearly equal to 550 tons per phase we are getting. Then which option is correct? It's a nearly 551 tons. That is option B is correct. Very good, very good. Come on students, 551 tons. See, fundamental question students, mainly concentrate. This is the fundamental equation of alternator. From this how the questions we can ask. That first I am explaining. This models is important 2 marks question in gate exam. Maximum in gate exam, EMF equation, we can expect the 2 marks question students. Very important models, please concentrate. How to apply the fundamental formula? First you concentrate that one. Very good Shobhi Sharma, it's a 550. Very good. But in the given option that I selected 551. One more question students. A 3-phase star connected synchronous generator running at 750 RPM. Come on students, come on. Running at 750 RPM. Generates a line to line voltage of 440 volts at 50 Hz on open circuit. The stator is wound with 2 slots per pole per phase and each coil has 4 turns. Assume full pitch coil. The useful flux per pole is. You want to find the useful flux per pole. Yes students, come on. Here given that full pitch winding, full pitched winding, full pitch. Full pitch coil means, full pitch winding or full pitch coil means Kp is 1. For full pitched winding Kp equal to 1 students, the pitch factor equal to 1. Point to remember, full pitched winding is given, you take the Kp equal to 1. Concentrated winding it is given, you take Kd equal to 1. If there is no data, how much slots it is short pitched, like that it is not given, always you take the full pitched winding. But here it is given that it is the full pitched winding, that's why Kp equal to 1. Kp is not the Kd. For concentrated winding, Kd equal to 1. For full pitched winding, Kp equal to 1 student. Okay, I calculated the Kp. Yes, the Kp I know. Then, yes students, first you calculate tons per phase. How to calculate tons per phase? The stator is wound with 2 slots per pole per phase. That is slots per pole per phase is 2. Slots per pole per phase is 2 students. Then what are the slots per pole? Slots per pole equal to 2 into 3. That is 6. But here how many number of poles it is not given. Then how to calculate? Ns equal to 120 F by P. Ns equal to 120 F by P students. Then I want P, number of poles. Yes, how to calculate 120 F by Ns? Can anybody answer? How many number of poles you got? 120 into 50 by how much speed it is given? 750. How many number of poles we can get students? How many number of poles we can get? Yes, come on. 8 poles we can get. Then how many number of slots? The number of slots equal to, yes, come on students, come on, come on. The number of slots equal to 6 into 8, that is 48 slots. The number of slots equal to, yeah. Why Manohar is the 16 slots? Slots per pole per phase equal to 2. Phase means it is a 3 phase. It is a 3 phase. 2 into 3, 6. Slots equal to 6 into 8. Very good. Manikanta. It is a 48 slots. Number of slots equal to 48 slots. But I want to find turns per phase. Okay. Slots per pole for. And each coil has 4 turns. Each coil has 4 turns, students. Each coil has 4 turns means total number of turns. Come on, students. How many total number of turns? Total number of turns. Calculate the total number of turns. Come on. Then what the total number of turns, students? The total turns equal to 48 into 4. How many turns we can get, students? 48 into 4. Come on, students. 192 we can get. But turns per phase I want. Turns per phase. It is a 3 phase. 192 by 3. Then how many turns per phase we can get, students? Come on. How many number of turns per phase we can get? How many number of turns per phase we can get, students? Yes. Yes. This is correct. How many number of turns per phase we can get? Can anybody? Come on. Very good. Yeah. I'm asking total turns. I'm asking turns per phase. I'm asking turns per phase. I'm asking turns per phase. Yes, students. How many number of turns per phase we get? Yeah. This is 192 by 3. Because each coil is having 4 turns. Then turns per phase equal to how much, students? 64. Very good. Yeah. I want to calculate KD. What is KD? Sin m gamma by 2 by m sin gamma by 2. M sin gamma by 2. Sin m gamma by 2 by m sin gamma by 2. What is m, students? Slots per pole per phase. How many number of slots it is given? How many number of slots, students? 48 slots. 48 slots. Per pole, how many number of poles? 8 poles. This is how much we can get, students. Come on, come on. How much we can get? Yes, students. How much you got? Yes. This is how much? 2. Slots per pole per phase is 2. Then you substitute here. Sin. I want to find slot angle. I want to find slot angle, students. First find the slot angle. What the gamma? Gamma equal to 180 into P by S. 180 into P by S. 180 into number of poles is 8. This is S is how much, students? How many number of slots? 48. This is equal to 30 degrees. Now you substitute here. Sin 2 into 30 by 2 by 2 into sin 30 by 2. Can anybody answer how much you can get KD? Can anybody? Come on. How much you got KD, students? How much you got KD? Very good, very. KD equal to 0.966. Very good, Amit. 0.966. KD equal to 0.966. Very good, students. KD equal to 0.966. Now you substitute the induced EMF per phase equal to E per phase equal to 4.44 F pi Kp Kd turns per phase. The induced EMF per phase is this in 3-phase line to line voltage is 440 volts it is given. That is 440 by root 3, students. 440 by root 3. This is 4.44. 4.44. Frequency 50 Hz. Pi is how much that you want to calculate. Kp is 1. Kd is 0.966. Tons per phase. How many number of tons per phase? 64. Can anybody answer how much flux you can get? Very good. Sharma, very good. Shushobit Sharma. Yes, very good. 0.966 I taken approximately. Now you tell the exact answer. What is the final answer, students? Come on. I'm expecting answer from you. How much flux you got? Yes, students. Come on, come on. Yes. Manikanta, how harmonics are reduced? Yeah. That I told in the previous session, Manikanta. There is a short pitched winding and there is a distributed winding. In a short pitched winding, by maintaining the short pitch angle, we can eliminate the nth order harmonic. That by using graphical also we can explain in the concept, but that I am not giving here. Mainly I am concentrating questions. Yes, Manikanta. Actually, to eliminate nth order harmonic, we are selecting alpha equal to 180 by n. This is mainly by using different winding procedures. By using different winding procedures, we are eliminating the different harmonics. Different winding procedures, we are eliminating different harmonics. By using short pitched winding, we can eliminate the low order harmonics. By using distributed winding, we can use the we can eliminate the spread harmonics. That is the phase belt harmonics. Phase belt harmonics are higher order harmonics. And we can also eliminate the slot harmonic by using integral slot winding. Using integral slot winding, we can also eliminate slot harmonics. Okay, these are by using different winding procedures. In the analysis, we can get that how we are eliminating the harmonic, students. Yesterday, in the previous session, I told, for example, to eliminate the nth order harmonic using short pitch winding, by maintaining short pitch angle, we can eliminate the nth order harmonic. Alpha equal to 180. For example, I want to eliminate a fifth order harmonic. What is the alpha? 180 by 5. That's why by proper selection of the short pitch angle, by proper selection of the phase spread, we can eliminate the harmonics. Mainly, triple N harmonics can be eliminated by using 120-degree phase spread. What is the phase spread? What is the phase belt? All this you know in the concept, but I am not giving that one, students. When I am explaining the concept, all these concepts I will explain. Yes. Yes, students. Yeah, that is the Manikanta. By using different winding procedures, we can eliminate the different harmonics. Yes, can anybody? How much flux you got, students? How much flux you got? Amit Das, you got 18.6 milliweber. Any answer? Any answer? Yes, students. All of you got same answer? All of you got same answer, students. Any answer? This is 440 by root 3, 4.44, 50 pi. That is Kp is 1, Kd is 0.966, tons per phase is 64. Any answer, students? You please do this one. How much flux per pole we can get? Okay, Manikant. How much flux per pole we can get? Yeah, that I am leaving for you. This calculation. You do that one, students. Exact value. Yeah, one more question is displaying on the screen. Come on, students. A three-phase star-connected alternator V1, V3 and the phase voltages. Then the line voltage is dash. Yes. Can anybody answer, students? A three-phase star-connected alternator V1, V3. I think all of you got 18.5 milliwebers. All of you got 18.5 milliwebers. Yeah. Yes. If any that options may be any wrong or otherwise you can try once again you try that calculation. Yes, friends, go for next question. You do that calculation. Calculation is in your hand. That is no problem. Yes, come on. Yes, students. A three-phase star-connected alternator V1, V3 and the phase voltages. Then the line voltage is Come on students. What is the line voltage? Yes friends. Point to remember, this is very important concept. You remember this note students. You remember this note. Very important. Yes friends. In star connection, phase voltages consist of third harmonics. That is triple N harmonics. Consist of triple N harmonics. Triple N harmonics. Yes friends. But line voltages does not consist of triple N harmonics. Does not consist of a triple N harmonics. It does not consist of triple N harmonics. Yes friends, please consider. If you take delta connection, phase and line voltages does not consist of line voltages EMF. The phase voltage means EMF. Okay, no need to write this one. Phase and line voltages does not consist of triple N harmonics. You know from the concept. Students. Yes, phase and line voltages does not consist of triple N harmonics. But that triple N harmonic current circulate within the phases. But triple N harmonic currents circulates within the phases. Yes, here I am writing. Yes friends, please concentrate. But does not consist of triple N harmonics voltages, but triple N harmonic currents. That is, but it causes circulating currents. Simply I am writing circulating currents within the phases. Yes friends. Now tell us friends. Here it is given that star connected, you want to find the line voltage. This line does not consist of triple N harmonics. Line voltages, sir, why it does not consist of triple N harmonics means if you calculate line to line voltage, that is, for example, I want VRY. How you can do VR minus VY? In this difference, automatically triple N harmonics will cancel. In this calculation. That's the reason why line voltages does not consist of triple N harmonics. It consists of only in phase voltages. But here it is asked star connected line voltage. What is the star connected line voltage equal to? √3 times of E phase. But I am writing √3 times of E phase. What are the phase voltages? V1, V3. V1 square. But it does not consist of which one, students? It does not consist of triple N harmonics. Why? It is a line voltage. Line voltage does not consist of triple N harmonics means √3 times of V1. Option C is correct. Come on students, very important. It does not, line voltage does not consist of triple N harmonics means don't consider this one in line voltages. That's the reason why actually square root of V1 square plus V3 square. But V3 is 0. That's why you can take √3 times of V1. Clear friends? Clear. Very important. √3 times of. For example, if it is asked what the phase voltage, phase voltage equal to square root of V1 square plus V3 square. This is correct. Phase voltages consist of triplen harmonics. Resultant phase voltage equal to square root of V1 square plus V3 square. This is correct, students. But here it is asked which one? Line voltages it is asked. In line voltages, triplen harmonics are 0. And you want line voltage means that phase voltage is multiplied with root 3. Multiplied with root 3. Is it okay, students? Come on. That is multiplied with root 3. Come on. Clear, friends? Yes. One more question is displaying on the screen. The phase EMF of a 3-phase 50 Hz alternator. The phase EMF of a 3-phase 50 Hz alternator consists of a fundamental 20% third harmonic, 20% third harmonic, 10% fifth harmonic. The peak value of fundamental voltage is 1000 volts. The RMS line voltage when the alternator is star connected. You want to find the RMS line voltage when the alternator is star connected, students. What are the fundamental, students? E1 peak. The fundamental peak value of fundamental it is given how much? 1000 volts. But I want RMS value. I want RMS value, students. That is 1000 by root 2. 1000 by root 2 is how much we can get? 707 volts we can get. Yeah, this is the RMS value. Next, consists of fundamental 20% third harmonic. What is the third harmonic voltage, students? 20%. 20 by 100 into 707. This is how much, students? Can anybody answer? How much we can get? 20% third harmonic is 20%. This is how much, students? Ashok, in the next, after completing the synchronous mission series, then I will start the power system, some topics also. Yes. Yes, students. E1 equal to 1000 by root 2, that is 707 volts. Then how much E3 you can get, students? Come on. E3 how much? It is a 20%. Third harmonic is 20%. 20% of the fundamental. This is how much you can get, students. Yes. Can anybody? How much you can get? This we can get 141.4 volts. Is it correct? 141.4 volts. Is it correct, students? Yes. The next one is fifth harmonic. Fifth harmonic is 10%. 10%. 10 by 100 into 10 by 100 into 707 volts. 10 by 100 into 707 volts. Yes. How much we can get, students? This is how much we can get? 70.7 volts. 70.7 volts. Clear, friends? Now I want resultant EMF. It is which one? Alternator is star connected. You want line voltage. What is the line voltage in alternator? Star connected alternator, root 3 times of square root of E1 square plus. But don't take third harmonic. Don't take third harmonic. E5 square. Clear, students? Don't take third harmonic. Don't take third harmonic. E1 square plus E5 square. Is it correct? Because in star connected, line does not consist of triplen harmonics. That's the reason why EL equal to root 3 times of square root of E1 square 707 square plus E5 square 70.7 square. Yeah, that's why I'm not considered third harmonic. In the just I calculated Manikanta, but I'm not considered in the calculation. Line does not consist of triplen harmonic. That's why I'm not considered that one. That's why I taken fifth order harmonic and fundamental only. I'm not considered the third harmonic. Is it okay, Manikanta? Here I'm not using. Just I calculated only. I just calculated only. I'm not using. But in the calculation of phase voltage, it consists. You want to calculate the phase voltage means then square root of E1 square plus E3 square plus E5 square you can calculate. But I am calculating line voltage. I taken only fundamental, only RMS. All these are the RMS values. And fifth order harmonic. Because I want line voltage in star connection. That's why I multiplied with root 3. Multiplied with root 3. Is it okay, Manikanta? Very good, Amit. How much you got, Amit? What? How much you got? I think nearly it is equal to 1230 point. It is nearly equal to 1230.8 volts. It is nearly equal to 1230.8 volts. Very good, Amit. Very good. Understand, Manikanti? I am not consider any third harmonic here because I am calculating line voltage. Clear? Yes, students. One more question, students. Come on. One more question. With respect to harmonics, also important. A three-phase four-pole, yes, 1500 RPM alternator has 60 slots with double layer winding. Conductor per slots are 10. Conductor per slot are 10. Winding is short pitched by 2 slots. The fundamental flux per pole is 100 milliweber. Third harmonic flux per pole is 10 milliweber. If it is a delta connected alternator, calculate the circulating currents. The fundamental reactance per phase is 10 ohms. Students, here fundamental is given. How much fundamental flux is given, students? Come on. How much fundamental flux is given? The fundamental flux is 100 milliweber. 100 milliweber. The third harmonic flux is how much it is given? Yes, students, 10 milliweber. But point to remember, students, you want to find the circulating current. Which causes the circulating current? Only triple N harmonics. In delta connection, triple N harmonics causes the circulating currents. In delta connection, yes, friends, in delta connection, triple N harmonics causes circulating currents. Causes the circulating currents. Therefore, how to calculate circulating current? IC equal to E3 by X3 plus E9 by X9 plus and so on. But here E9 it is not given. That's why ninth order harmonic it is not given. That's why you take this one. Then what the circulating current, students? Only third harmonic is given, E3 by X3. You want to find the E3. That means in this problem you find the E3. Already fundamental reactance is given. How to write in terms of fundamental reactance? X3 equal to 3x1. X3 equal to 3 times of x1. That is the E3. That is the X3, students. That is third harmonic reactance equal to 3 times of the x1. That means if you want to find the circulating current, find the E3. Find the E3. Come on, students. How to calculate the E3? Please concentrate on the concept. First I am writing the E3 for phase is equal to 4.44 F3 pi 3 Kp3 Kd3 tons per phase. Clear, friends? What is F3? F3 equal to 3 times of F1. 3 into 50 H. How much you can get, friends? 150 H. Okay. One parameter is over. How much frequency it is given? It is a 3-phase 4-pole. If the frequency is not given, then you calculate this one. What is F equal to? Ns into P by 120. Yes, friends. Speed is 1500. Yes, speed is 1500. How many number of poles it is given? 4 pole into 4 by 120. How much we can get, friends? 50 Hz. That I calculated. This is the fundamental frequency. Third harmonic frequency is 3 times of F1, 150 Hz we can get. Pi 3 already given. What is the third harmonic flux it is given, students? Come on. What is the third harmonic flux it is given? 10 milliweber. It is given that 10 milliweber. Directly it is given 10 milliweber. Okay, students. Now I want to find Kp3, Kd3. How to calculate Kp3? This I already told that. Cos 3 alpha by 2 Kp3. Then you want to find alpha. Alpha is how much it is given, students? It is short pitched by. Winding is short pitched by 2 slots. Winding is short pitched by 2 slots. Alpha is 2 slots. Then you find the slot angle. Slot angle equal to 180 into P by S, students. 180 into P by S. This is 180 into how many number of poles, students? 4 poles. How many number of slots it is given? How many number of slots? It is a 60 slots. The number of slots equal to 60 slots. Then how many degrees we can get, students? Come on. How many degrees we can get this one? This is 12 degrees. This alpha equal to 2 slots. 2 into 12, that is 24 degrees. Then we calculate Kp3, students. Kp3 equal to cos 3 into 24 by 2. Can anybody answer how much Kp3 you got? Can anybody answer how much Kp3 you got, students? What the Kp3 value you got? This equal to 0.809 you can get. Is it okay, students? 0.809. Now I want to calculate KD3. KD3. How to calculate KD3? That is sine, yes students, 3 m gamma by 2, because it is a third harmonic. M sine 3 gamma by 2. M sine 3 gamma by 2. This is KD3, students. You know this formula. KDN equal to sine n m gamma by 2 by m sine n gamma by 2. M sine n gamma by 2. This is the KDN. I want third harmonic, means this I substituted. What is M, students? Slots per pole per phase. Per pole per phase. How many number of slots it is given? Come on, students. How many number of slots it is given? Yes, 60 slots. How many number of poles? 4 pole, 3 phase. This is how much you can get? 5. Then you can calculate KD3. Can anybody answer how much KD3 you can get? Yes, Kp3 is 0.809. How much KD3 you got, students? You can get 0.647. You substitute all these, we can get 0.647. Clear, students? Now I want to calculate E3. Then E3 per phase equal to 4.44. Pi 3 is how much, students? 10 milliwebers. 3 into F1. 3 into 50. Yes, friends. Kp3 is 0.809. KD3 is how much, students? Okay, clearly I am writing. Please concentrate. I am writing clearly. Come on, students. Come on. You calculate E3 per phase first. Important for 2 marks. E3 per phase. Then E3 per phase equal to 4.44. Pi 3 is 10 milliwebers. 10 into 10 power minus 3. Yes, friends. This is 150 hertz. 150 hertz. Kp3 is 0.809. KD3 is 0.647. You want to substitute tons per phase. You want to substitute tons per phase, students. How many number of tons per phase it is given? You want to calculate tons per phase. Yes. 60 slots with double layer winding. Conductors per slot are 10. Conductors per slot is 10, students. Conductors per slot is 10. Then total number of conductors is how much? Z equal to total number of conductors is how much? 60 into 100. 60 into 10, 600. How many number of tons? 600 by 2. This is 300. How many number of tons per phase? The number of tons per phase equal to 300 by 3. This we can get 100. Clear? Clear, students? Total slots is 60. Given the double layer winding. Given the double layer winding, students. Given the double layer winding. 60 into, then double layer winding number of slots equal to number of coil. Per coil, the slots equal conductors per slot. Per slot, how many conductors? 10. 60 into 10, 600 conductors. 600 conductors means how many number of tons? 300 tons. 300 tons. But how many number of tons per phase? It is a 3-phase alternator. 300 by 3, 100. 300 by 3, it is 100. Clear, students? This you substitute 100. Then how much you can get? Can anybody answer this one? How much induced EMF E3 per phase you can get, students? How much E3 per phase you can get? How much E3 per phase you got? Can anybody? Come on students, come on. How much E3 per phase you got? Please do that one. 4.44 into 10 into 10 power minus 3 into 150 into 0.809 into 0.647 into 100. Come on. Yes students. Very good Amit. 348.7 348.7 volts. Then I want circulating current. IC equal to E3 by 3x1. E3 by 3x1. 348.7 by, because given the fundamental reactance, given that fundamental reactance 10 ohms per phase, 10 ohms per phase into 10, then how much circulating currents we can get? Yes. Yeah. Manikanta, in double layer winding, number of slots equal to number of coils. But in single layer winding, number of slot equal to 2 into number of coils. Number of slots equal to 2 into. That is double the number of coils are required. More number of slots is required in single layer winding. In double layer winding, number of slots equal to number of coils. Number of slots equal to number of coils. Number of slots equal 2 times of number of coils, that is the single layer winding. That difference only you remember. But placement of winding is also different. Double layer winding means in each slots 2 coil sides are placed. In single layer winding, in each slot only one coil side is placed. Only in one coil side is placed. Then how much we can get students? This is 348.7 by 30. Yes. How much you got students? How much circulating currents we can get this one? I think it is nearly equal to 11.6 amperes you can. 11.6 amperes. It is nearly equal to 11.6 amperes. Is it correct students? This is equal to option D. Option D is correct. And one more point students, this problem you done that calculation I given. Here assume that it is a double layer winding. Assume full pitch coil, double layer winding. It is also double layer students. With this assumption only I solve this problem. Double layer winding. Here if option is not there, approximate value you can select by doing the calculations. In that if any mistake is there in calculation, please rectify that one. You do that calculation in that problem students. I'm leaving for you that calculation. Yes, we are getting 11.6 amperes. We are getting 11.6 amperes. Yes, one more example students. Yeah, come on, come on. Yeah, this, yes friends, very important model for gate point off. Very important model for gate point. Very important formulas also I will give you. Please concentrate. The flux distribution in the air gap of synchronous generator is, that means in the air gap of synchronous generator, it consists of fundamental, third harmonic, fifth harmonic. If the total flux per pole is 0.08 Webers, the coil span is 0.8 of the pull pitch. Find the fundamental induced EMF in one term at 50 Hz frequency. Yes friends. Find the fundamental induced EMF in one term. One term means slots per pole per phase is one term. Slots per pole per phase is 1. If the slot per pole per phase is 1, KD1, KD3, KD5 and so on, KDN is equal to 1. That's why no need to calculate KDN. Slots per pole per phase is 1. We are maintaining only one conductor slots per pole, one turn. Then we can say that it is a concentrated winding. Then slots per pole per phase equal to 1 students. Okay, KD1 or KD3 or KD5 or KD1, any value you can take, this is equal to 1. Okay, no need to calculate it. But here it is asked only fundamental EMF. It is asked remaining, there is a third harmonic EMF, there is a fifth order harmonic EMF also, but that is not asked in this problem. It is asked only fundamental EMF. First write down the formula for fundamental EMF students. E1 equal to 4.44 F1 by 1 KP1 KD1 tons per phase. Tons per phase. Here tons per phase is 1. Tons per phase is 1 only. It is given that tons per phase induced EMF in one term we want to find. In one turn you want to find, that's why you take turns per phase equal to 1. Yes, pi 1, this is 50 Hz frequency. Fundamental frequency is 50 Hz frequency. Okay. That is F1 also I know. F1 also I know. Then I want to find phi 1. But total flux is given. Total flux is pi 1 plus pi 3 plus pi 5. Pi 1 plus pi 3 plus pi 5. Total flux. But I want pi 1 because I want to find fundamental EMF now. That I want pi 1. Then how to calculate that pi 1? For that we can use some relations. What the total flux? 0.08. 0.08 equal to pi 1 plus pi 3 plus pi 5. Okay. But one important relation, students. One important relation. Very important. I am not giving derivation for this one. Pi n by pi 1 equal to 1 by n into bn by b1. This is the relation between, in harmonics, nth order harmonic flux and nth order harmonic flux density. Pi n by pi 1 equal to bn by b1. Very important relation, please concentrate. For example, I want pi 3 by pi 1 because I want to find the pi 1, students. First I want to replace this pi 3 in terms of pi 1, pi 5 also in terms of pi 1. Then I can get the pi 1. Then I want to find pi 3 by pi 1. Then how to get pi 3 by pi 1, students? Then pi 3 by pi 1 equal to, replace n equal to 3. 1 by 3 into b3 by b1. b3 by b1. Then what is the pi 3 by pi 1 equal to 1 by 3 into, yes, here the relation is given. What is the relation between b3 and b1? Come on, students. b3 by b1, what you can get? You bring this side, b3 by b1 equal to 0.3 you can get. b3 by b1 equal to 0.3. Then what is the pi 3, students? 0.1 times of pi 1. Similarly, I want to find pi 5 by pi 1. Replace n equal to 5. 1 by 5 into b5 by b1. b5 by b. Come on, students. Very important modular problem. Very important relations also. 1 by 5 into, what the b5 by b1, students? You take this relation. What the b5 by b1? 0.2. From this one we can get the 0.2. b5 by b1 is 0.2. Then how much pi 5 you can get? 0.04 pi 1. 0.04. Then what the total flux, students? Pi 1 plus pi 3 plus pi 5. Okay. Then what is pi 1, pi 3? Pi 3 equal to 0.1 times of pi 1. What is pi 5? 0.04 times of pi 1. Then from this, what is the pi it is given? 0.08. How much total pi it is given, students? 0.08 Webers it is given. This we can simplify this one. How much you can get? 1.14 pi 1. Then from this, what is the pi 1? Now I got the fundamental flux. Now I got the fundamental flux, students. How much pi 1 you got, students? Can anybody? How much pi 1 you got? How much pi 1 you got, students? Yes, this is pi 1 equal to 0.08 by 1.14. Please do this calculation. What is pi 1 you can get? Anybody, students? This we can get 0.07 Webers. 0.07 Webers we can get. Pi 1 equal to 0.07. Yes, I know the pi 1. Pi F1 you know, pi 1 you know, KD1 already 1 because of one term. I want to calculate KP1. To calculate KP1, coil span equal to 0.8 times of full pitch it is given. Beta equal to 0.8 times of full pitch. This is pole pitch. It is given that 0.8 times of which one, students? It is not full pitch. It is a pole pitch. Please correct this one. 0.8 times of pole pitch. 0.8 times of pole pitch, students. It is a 0.8 times of pole pitch means how many degrees? 180 degrees. This we can get 144 degrees. Then what is alpha, students? 180 minus beta. That is 36 degrees we can. What is the Kp? Kp equal to cos alpha by 2. Cos 36 by 2. Cos 18. Can anybody, what is the Kp you can get, students? How much Kp you got? Can anybody? This is equal to 0.95 you can. Then what is the fundamental induced EMF per phase? What is the fundamental induced EMF per phase, students? Then the induced EMF per phase equal to 4.44 50 hertz. Pi 1 is how much you calculated? 0.07. This is 0.95. This is 1 into 1. How much induced EMF per phase we get? Can anybody? Yes. Panwar, good afternoon. Manikanta. Yes. Can anybody, friends? 4.44 into 50 into 0.07 into 0.95 into tons per phase is also 1. Yes, KD1 is also 1, students. How much induced EMF per phase you got? Come on, students. How much induced EMF per phase you got? Does speed and flux have relation in induction and synchronous machines? Yeah. You can relate frequency, induced EMF you can relate. Manikanta, E equal to 4.44. In that relation, we are getting the frequency. Sorry. Yes. We can relate with frequency in synchronous machine. Manikanta, you relate with you can relate with frequency. 4 point. Actually, it is a constant. In synchronous machine, it is a constant speed. They are taken, it is a constant speed. Then induced EMF depends on the frequency. Induced EMF depends on the frequency. Then you relate that NS equal to 120 F by. From that only you can write the relation. If you assume that constant speed, then it is independent. E1 per phase equal to how much? Very good, Amit. 14.76 volts we get. Very good. 14 point, because induced EMF depends on the frequency. You know that frequency depends on the speed. NS equal to 120 F by P. Like that we can relate. 14.76 volts we can get, students. Very good. Option A is correct. This model is important for 2 marks question in gate exam. And one more note I am giving, student. This formula also you remember. Note I am giving. Here one more note I am giving, student. This formula also you remember. Very important. En by E1 equal to yes, friends, Bn by B1 into Kwn by Kw1. Kwn by Kw means it is a winding factor. K suffix W. Kwn by Kw1. Then from this, once you know the fundamental, any harmonic EMF is also calculated. Once you know the fundamental, any harmonic EMF is also calculated, students. Kwn by Kw1. What are the Kwn, students? What are the Kwn? Can anybody? What are the Kw? It is a winding factor. Nth order harmonic winding factor. This Kwn equal to Kdn into Kpn. Kdn into Kpn. Kw1 equal to Kd1 into Kp1. Kd1 into Kp1. Like this you can. Now, this is also important. For example, I know the fundamental EMF. Then I want third harmonic. Use this relation. Fifth order harmonic. Use this relation. Yes, friend. This is also important formula. You please concentrate. Is it okay? Yes, students. Generally, Manikanta, during calculation of excitation EMF, then we are not considering that speed. We are assuming that in synchronous motion, the speed is constant. Yes. But where generated EMF, you take that generated EMF, in the case of DC motion, that depends on the speed. But here excitation EMF is independent of the speed, because we are assuming that constant speed, then frequency is also constant. Constant speed and frequency is also constant. Yes, friends. Okay, these are about the different models of questions based on the EMF equation. These questions I am giving assignment for you. These questions I am giving assignment for you. You please try to answer these questions. If you have any doubts, clarification, and during solving of these problems, you please share your doubts in my Telegram. For time being, I am ending the session. You please share your doubts in my Telegram channel, students. Assignment I am giving, please concentrate. This also assignment. You please try to answer these questions, students. Okay. Yes, students. Yes. Mainly in induction generator. EMF means mainly concentrate on induction generator. But in induction motor, the speed. In induction motor, we are taking the speed with respect to frequency, not the generated EMF. Generally, we are talking about induction motor means we are taking the speed. But in the case of induction generator, based on the speed, the induced EMF will changes. It is a variable speed machine. Induction generator. If the speed is changes, the generated EMF is also changes in induction generator. It is a variable speed. Because if the speed is changes, slip is changes. If the slip is changes, rotor frequency changes, then the rotor induced EMF is also changes. The rotor induced EMF is also changes. Because it is slip times of frequency. FR you take, FR is slip times of frequency. If FR is slip times of frequency, if you change the speed, what is the slip? Slip is changes. If the slip is changes, FR will changes. If FR will changes, what the induced EMF is also changes. Like that you consider the money. Is okay? Yes, friend. This is about today's session. This is our GATE 2022 champion study plan. Please go through the schedule. Yes, friends. This is my Telegram channel. Who are not joined still now, you please join for more updates about my lectures. And if you have any doubts clarification also, you please share your doubts. Whatever the homework assignment I given, you please do that questions. And if you have any doubts during solving of that problems, please share your doubts in the channel, students. This is our Gradeup Super, students. Please concentrate. Please concentrate. Yes, friends. I am ending the session. Thank you, Amit. Thank you, Manikanta, Rahul. Yes, Panwar. Yes, all of you, thank you very much, students. Shobhi Sharma, Manohar, Mani, all of you, thank you very much, students. I am ending the session. Is it okay, Manikanta? Understand? In case of induction mission, if the speed changes, slip will changes, slip changes, slip frequency changes, that is rotor frequency will changes, induced EMF is also changes. Thank you very much. I am ending the session.